Well, hello team, welcome to the last lesson in Unit 0 Algebraic Tools. This is Lesson 6, Solving Literal Equations. This lesson did not used to be in Unit 0, the master unit, but I realized partway through the course that not having mastered this skill was actually interfering with a lot of my students' success. So we've added this into the Unit 0, and this is the unit where you have to get 100% on the test. In order for us both to be happy with your progress in the course. So we're solving literal equations. I also know that your physics teacher at school here would really appreciate if you have this skill already going in, because most of the formulas in physics need to be rearranged. And I know that you'll use these skills a lot in grade 12 advanced functions and also in calculus. Okay, so solving literal equations, what are we really looking at here? Well, formulas are equations that express a relationship between more than one letter or variable. But it's also called a literal equation when it involves several variables or letters. So sometimes what we need to do is use algebra to first rearrange a formula to a more useful equivalent equation. So you're isolating a different variable than the one that's being isolated when you get the equation. And the steps used are really similar to just solving linear equations. Essentially, whatever you would do when evaluating using BEDMAS, we're going to undo that in the reverse order when rearranging to isolate a variable. Let's look at a few examples together, and we'll start with simpler ones that you've seen more often, and we'll work to ones that are a little more complicated that may be different than ones you've seen before. So if we want to solve d equals r times t for the variable r, then we're just looking to isolate the variable r. The key thing here is to just say, okay, R, what's happening to you? Imagine that R used to be happy and by itself on one side of the equation, but then something happened to it, or a series of things happened to it. And in this case, R would be alone if it weren't for this T multiplying itself. And that's the only operation that's happening on R. So the opposite operation of multiplication is division. All we need to do then is to divide both sides by T to isolate R. And at that point, R is equal to d over t. There's no further work we can do. If this were numbers instead of variables, then we'd have to simplify further and evaluate, possibly. But because we're working with just variables and in some ways solving literal equations, once you can get your mind around it, is a little bit easier, because all you have to do is undo operations and then you're just left with the result that you have. At this point, if we knew what d and t were, we could substitute them in and evaluate for r. But we're not going to do that. Right now we're just practicing rearranging them for different variables. So we want to solve p equals 2l plus 2w for the variable w. We want to rearrange the equation to isolate w. So again, if we look at the original equation, I can see that w, it used to be by itself at one point. First, it got multiplied by 2, and then that product got added to 2l. So if you were w and you saw things were happening to you, first you got multiplied by 2, then you got added to 2l. So if we wanted to undo that or peel back the layers and get w out, dig w back out of this equation, then we're going to undo the last thing that was done. And since the last thing done was adding 2l, first thing we'll do is subtract 2l on both sides. So we end up with p minus 2l equals 2w. So we're getting closer. We're getting almost, we got w isolated. We're just going to look at dividing both sides by 2, since that's the last step, 2 times w. And then you end up with w equals p minus 2l all over 2. Watch out for this, that if you're going to divide one side by 2, that you are dividing the whole other side by 2. So that means that this binomial is getting divided by 2. And if you find it helpful, then go ahead and put a set of brackets around it. The only mistake that I would see in a question like this, if students were rearranged to isolate, would be just putting the p divided by 2 or just the 2l divided, like forgetting that the whole binomial needs to be divided by 2, that both sides of the equation are being divided by 2. Example 3 here, we're going to look at solving q equals c plus d over 2 for d. My recommendation is that when you see an equation, a literal equation that you're looking to solve for a different variable, I would consider any denominators to be a problem that you want to deal with first. So in my opinion, the best thing to do right away is to just get everything up in the numerator so that you've got, product or sum equals another product or sum. And instead of having a quotient here, let's undo that dividing by 2, and we'll just clear that fraction. We'll multiply both sides by 2 so that we end up with 2q equals c plus d. And now that that 2 is no longer a problem, now we can say, all right, I'm isolating d. And the only thing happening to d here is that it's having c added onto it. So we'll subtract c from both sides, and we just end up with d isolated equal to 2q minus c. Okay, so the strategy here is just to notice, let's consider denominators to be an issue that we want to resolve. Okay, if we look at example 4, we're going to resolve this issue as well. We've got v equals 3k over t. We want to isolate t. If t is in the denominator, you're thinking, well, how can I isolate that? How can I get that out of there? Remember, just consider denominators to be a problem that we want to fix first. So we'll multiply both sides by t, and then we end up with tv equals 3k. And since we want to isolate t, t's up here in the numerator with v, being multiplied by v, so we can undo that by dividing both sides by v. So we end up with t equals 3k over v. Okay, so just watch out for that. Get rid of your denominators if you can. Consider them to be a problem that we'll fix first. Okay, that's one issue. Another issue that you might see is that the variable you want to isolate is actually repeated more than once in the expression. So because we've done so much factoring, this is a really good time to introduce this idea where instead of 3a plus 5ac, if you just want 1a, then get all the a terms on one side of the equation, and once you've got all the a terms on one side of the equation, common factor the a out. In this way, instead of a being repeated twice in two terms that are being added together, we now have a product of a times a binomial. So we've common factored that a out, and now this one and only a is going to be much easier to isolate because it's being multiplied by this binomial. So now just by dividing both sides by that binomial, we can isolate our a, and in this case, a will equal 3 plus 5, or r over 3 plus 5c. Example 6 here is just going to take the example 5 one step further. Okay, so notice that we want to solve for h. We want to rearrange this equation to solve for h. And I can see that h is repeated twice. Okay, so on this side of the equal sign, we have a in two of the terms. So if I look at this 1/2 ah minus 1/2 bh, what I think I'll do is I'll common factor out the half and I'll common factor out the h. So that again, instead of two terms, now we've got a product of three factors, 1/2 times h times a minus b. And if I want to isolate the h, I'm going to say, all right, same rule that we were using before. I'm going to consider this denominator to be an issue that I want to resolve first so that I can deal with everything else. I'm going to multiply both sides by 2 so that we end up with 2a equals h times a minus b. And since we want to isolate the h, but it's currently being multiplied by a minus b, we undo that by dividing both sides by a minus b, and then we get h equals 2a over a minus b. Okay, so the strategy here again was to common factor out the variable that you're looking to isolate if you see it in more than one term. And the first step, if they're not already on one side of the equal sign, is to put all the terms that contain your variable on one side of the equation and all the terms that don't contain your variable on the other side. And then that way, as you start to factor, you can isolate your variable faster. All right, last two examples here. Number 7, solve for a equals pi r squared s over 360. We want to isolate s. Again, we're going to just consider 360 to be a little problem we want to fix, so we're going to multiply both sides by 360. Before all the work here is done, what we'd end up with is 360a equals pi r squared s. And if we want to isolate s, we can see that s is just being multiplied by pi and r squared, so we can divide both sides by pi r squared. And pi r squared divided by pi r squared gives you 1. And 360a over pi r squared will be our s, will be our expression for s. If we take the same expression, but this time we want to isolate r, we're going to have a similar process. I'd like to multiply both sides by 360 right away. We're just going to eliminate the denominators or clear the fractions first. Then we end up with 360a equals pi r squared s, which is just what we had in the previous example. But this time I want the r by itself, so first I'm going to isolate the r squared, so we divide both sides by pi s. At this point we get 360a over pi s equals r squared, and if we just want r, then we have to square root both sides. Generally speaking, when you have to square root both sides of an equation to isolate a variable, you have to take plus or minus the square root of the expression. But in this case, because r is representing the radius, we are going to recognize that we can't have negative values for the radius. So rather than do plus or minus for this one, we're just going to keep it as positive, so that the radius will be the positive square root of 360a over pi s.